In the third part of this tutorial, we're going to run a particle model. And what we're going to do is we're going to simulate floats using the results, the hydrodynamic results, and see which paths they travel. Now in the assignment you might want to do this to compare with the oranges that we're going to drop off the boat and track for a couple of hours. So we're going to use the PSED model. And PSED is essentially a Lagrangian sediment transport model. And it in essence computes the movement, advection, dispersion and settling of sediments. It can be used for what-if scenarios to, for example, look at the fate of dredging. And it basically, PSED is a separate model, but it uses Telemac results, Telemac hydrodynamics, and you can give it a range of different sediment properties from silts through to gravels. Now it doesn't have any morphological changes, so it doesn't change the bed, there's no interaction, so if the sediment falls it changes the flow, it's just a sort of one-way coupling, so the flows influence the sediment. And there's more technical detail on Blackboard. Now before we can run PSED, we actually need to save the results in a format that PSED can use. So what we're going to do first of all is click on bottom, go File, Save Copy As, and be very, very careful here in that you need to save it in precisely the right format. If you don't, PSED won't run. And so just be careful. And my computer's just being a bit slow again. So what we need to do is save bottom, and what I'll do is save it in day 4. And I'm going to save it as the word depth, not depth, sorry, bathy. And this one you save as ASCII single frame, so just the default. That's fine, so let's save that as bathy. Okay, now what we're going to do is click on water depth, go File, Save Copy As. Now be very careful, this time we want binary multiframe. If you don't get this right, it won't work. And here we're going to save this as the keyword depth. Okay, make sure it's binary multiframe, and then if we go to velocity, now velocity, I'll save copy as, and this one also needs to be multi-frame, and this one we are going to save as the keyword velocity, binary multi-frame. Let's check I've got that right. Yeah. Okay, now we can actually set up PSED. So what we'll do is once that's saved, we'll open a PSED model. So we'll go File, New, PSED Run, down the bottom. And this is where we set up the run. So what we're going to do is we're going to run the time step as being 15 minutes, the duration as being 10 days, so this is hours, 240 hours. Okay, we're going to tick most of these properties here, and then we're going to go through to the hydrodynamics tab. The temperature we're going to set as 9 degrees, the salinity is 30, but you, on the boat and when you come to run this in your assignments, put in realistic values. We'll have a CTD on the boat, so you can put in realistic values. Now here we need to load in the file. So this is the bathy file that you created. Go to the depth tab. This is the depth file you created. Go to the currents tab. This is the velocity file you created. So that's the actual hydrodynamic data that's going to run. Waves and bed we can just leave as default. So first of all, let's go to properties and we'll use silt. And go to source, and here we need to give it a location at which we're going to release these particles. So we're going to release silt particles. So if you put in 619852, this is going to be a location at the mouth of the solent, somewhere around here. 5, 6, 3, 1, 8, 9, 6. And we're going to release the particle. Let's release it for quite a while, 10 hours. We're going to continually release sediment for 10 hours. Okay, now we can click apply and go OK. Now what we need to do is go to run and check the parameters. And basically what it's telling us is that everything's set up okay. So hopefully when we go to run and launch simulation, save PSET there, it should launch and start running now. Now it'll take a few minutes to run just because we're continuously releasing sediment for 10 hours. So remember it's running for 10 days. You can see it's done the calculation so far for 3 of the 10 days. So we still have to wait a few more minutes. It's 4 days now. So about halfway through. Okay, so we're almost there. Okay, that's completed. If you just press return, that's finished. So now we can go to run, load results, and what you'll see is a file will appear down here, a tab will appear down there with the results. And this essentially just contains the Lagrangian particles and sort of where they are. So what we can do is drag that to the 2D view like you've done before, just right click and animate. And what we can see now is that's the particle there, and we can see the sediment being released, and with the tide we can see it going in and out of the estuary. What you could do is have a time series here below to see what the time of the tide are. So you can see that the sediments are starting to go into the handle. The ones that are red are deposited on the bottom, so you can get a feel for sort of where the material is going. And that is the Lagrangian tracking model. And what you could do just to end is you could rerun the model with your results from the Bramble Bank raised and see if the particles follow different tracks. Okay, so that is the end of practical 4.